As you know by now, Jim Coleman Company is committed to manufacturing world-class equipment with a goal of generating income 100% of the time. We're providing this service video to illustrate various components and functions of your Water Wizard and step-by-step instructions for service. If a problem should occur, this video coupled with the Water Wizard manual will be a great tool to expedite a solution and get you back in business. We must first caution you. Due to high voltage present, this service video is meant for qualified technicians only. A working knowledge of voltmeters and other specialized tools is required. The video is divided into various subject matters designed to make it easy to locate the area that pertains to you. Jim Coleman Company appreciates your efforts in supporting our goal of 100% uptime. Together we can make the Water Wizard the in-bay touch-free automatic all others are compared to. The pumping plant is the heart of the Water Wizard. It supplies the high-pressure water and all the chemical delivery to the wash bay. It is a compact, modular system designed to occupy minimal floor space. Let's take a quick look at the pumping plant. The pumping plant begins with a 2-inch stainless steel framework. The stainless tanks support the framework. The largest tank holds fresh water for the high-pressure portion of the wash cycle. Water enters through a 1-inch port using a Hydraminder to control the level. Water exits the tank through a 1.5-inch port that is controlled by a ball valve. The chemical tanks are adjacent to the water tank. Water enters and exits these tanks in the same manner, but with smaller inlet outlets. Inside, Hydraminders control the water level and blend chemical and water to the correct ratio. These tanks have filters on the outlet port. The Procon pumps deliver the mixed chemicals to the wash bay. They're mounted below the chemical tanks, directly onto the electric motor that powers them. Gauges that indicate the Procon pump's operating pressure are mounted above the chemical tanks, directly behind the corresponding pump. Each pump delivers its product directly to the wash gantry through color-coded hosing. A CAT 3535 ceramic plunger pump delivers high-pressure water. It's powered by a 25 horsepower, 220 volt, 3-phase motor and a belt drive system. The pump's inlet is on the bottom side of the pump head. Solenoids controlling high-pressure chemical injection for functions such as wax and high-pressure soap are located on the inlet side of the pump head. The top outlets of the pump head are the high-pressure outlets. The pressure gauge and bypass regulator are on the outlet. Undercarriage and medium pressure solenoids are located on the bottom and near the center of the framework. A number of components are assembled in a small but serviceable area. This makes the Water Wizard pumping unit an easy fit for nearly all equipment room configurations. The Hydraminder is an automatic mixing valve operated by a float control and constant water pressure of 40 to 60 psi. When the float drops low enough to open the valve, water flows through the diaphragm, then through the inductor. As water flows past the inductor, it creates a venturi that draws chemical from the storage tank through the siphon hose. The siphon hose connects the Hydraminder to the chemical storage tank and must stay full to ensure proper chemical mixture. If the hose drains after each use, check the operation of the foot valve and replace if necessary. The amount of chemical is controlled by plastic tips with a precisely sized orifice. This tip is inserted in the chemical inlet. They are color-coded and come in a variety of orifice sizes that allow you to change the ratio of chemical to water according to the chemical manufacturer's recommendations for vehicle application. Other components of the Hydraminder include: there's a screen on the inlet of the Hydraminder in each chemical tank. Screens must be kept clean. Some turtle wax chemicals, such as triple shine foaming conditioner, are highly concentrated. Hydraminder mixing valves will not dilute the concentrate to a small enough ratio with a single tip arrangement. Therefore, the product should be double diluted. Chemical suction from the storage tank is the same for the first tip. The specially designed double tip assembly allows the chemical mixture created by the first tip to be mixed again with another water supply. This is a gasket material used to open and close the valve as controlled by the float. The diaphragm must be clean and free of debris. The on-off control of the Hydraminder is controlled by a float that raises and lowers with the liquid level. The float is weighted so it will pull down on the valve control when product drops below a set level. Make sure the float is not restricted as it travels. An outlet hose is attached to the Hydraminder to keep high-foaming products from overflowing the chemical tanks. A small hole in the hose can be seen above the water level. This serves as a siphon breaker so chemicals will not be siphoned out of the tanks. If a Hydraminder sticks open, fails to open, or does not mix chemicals as originally set up to do, it requires service. First, verify the water pressure on the inlet is between 40 to 60 psi and the float is not restricted. Then confirm there is chemical in the product tank and siphon hose is full of chemical. A small air pocket at the top of the hose bin is normal. If the Hydraminder in either the water tank or the chemical mixing tank is stuck open or will not open when called for, the first step in repair is to close the quarter-turn valve and remove the black plastic switch cover. Then remove the float bail and the magnet and spring. Expose the diaphragm by removing the top portion of the valve body. Check for debris or a badly worn diaphragm. If the diaphragm is bad, replace it and reassemble the valve body in the opposite order. If there is not enough chemical in mixture, check the tip for blockage. Again, ensure the chemical siphon hose is full of chemical at all times. Check for worn tips if chemical mixture is stronger than originally set. Because the tip orifice is sometimes very small, it is hard to determine if the opening is changed. Since tips are relatively inexpensive, it is suggested to change the tip. Match the new tip color for color and retest for proper mixture. Remember, consistent water pressure is critical to consistent chemical mixture. Check incoming water pressure when all other pumping equipment is operating. Pressure may be satisfactory when no equipment pumps are running and drop considerably when equipment such as a water wizard begins its high pressure passes. Each chemical delivery pump is protected by an electronic float switch located in the chemical mixing tank. If the tank level is allowed to drop below the float switch, the system will disable that pump, send an error message to the electrical control panel which will display the message on the operator interface screen, and print it out if optional printer is installed. All chemical products are delivered to the wash bay by Procon pumps with the exception of the high-pressure wax and high-pressure soap. These are drawn into the inlet of the CAT 3535 pump during the high-pressure passes. The Procon pump is an extremely reliable pump that provides a constant product delivery. On the pump stand are two different sizes of pumps. The pre-soak pumps, both high and low pH, are stainless steel. The tire cleaner and triple shine conditioner pumps are brass. To remove a pump, loosen the collar and pull the pump off the connecting shaft. To replace it, line the connecting shaft with the opening and insert until pump body is flush with housing. Position the collar over both rings and tighten it securely. The motor driving the pumps are 220-volt single-phase motors. These check valves stop the backflow of chemicals. The pressure gauges are located on the front of the pumping plant. The pump should be flowing 50 to 60 psi. To adjust the pressure of the Procon pumps, remove the cap nut to expose a threaded adjustment screw. Using a flat blade screwdriver, turn screw clockwise to increase pressure. All pressure adjustments should be made while the pump is running and product is flowing. While the cap nut is removed, it's common for a small amount of product to leak. The cap nut includes an O-ring designed to seal off the adjustment screw. The shutoff valves located on the back of the pump unit will allow you to shut off flow of product for service or repair of the chemical delivery pump. The valve must be open any time the pump is operating. Failures to do so will cause unnecessary damage to the pump. The flow of the chemical product will begin by passing through the filter in the Hydraminder tank, past the quarter turn valve, and into the Procon pump. The pump pressurizes the product to 50 to 60 psi as it flows to the gantry's low-pressure solenoid manifold box. When called for, each corresponding solenoid will open to allow product flow. Tire cleaner, pre-soak, and triple shine open up an air solenoid simultaneously. These solenoids are also located in the low-pressure manifold box. The product solenoids are full flow and do not have regulators on them. The air solenoids do have a regulator. The adjustment of airflow should always be less than the product flow pressure, usually a 10 to 15 pound difference. The exact amount lets you determine how foamy in appearance each product is at your site. The CAT 3535 pump provides the high-pressure water flow. It's used for all high-pressure passes, including rocker panel sprayers and undercarriage wash. Under normal conditions, this pump will be in service for several years with minimal maintenance. It is powered by a 25 horsepower electric motor operating on 220-volt three-phase power and a 3-belt drive system. The CAT 3535 pump is a ceramic plunger pump that is designed to flow 35 gallons per minute. The Water Wizard flows 32 gallons per minute at 1,000 psi during the high-pressure passes. The pump has 3 valves each on the water inlet and outlet. For detailed information on the CAT 3535 pump, see the CAT pump section of the Water Wizard manual. All CAT pumps have an oil level viewing window at the rear of the pump. Oil levels should be touching the red dot located in the center of the window. Too much oil or too little oil can cause problems. The proper levels should be maintained and checked often. The CAT 3535 pump should be operated at 1,000 to 1,100 psi. This is adjusted by the bypass regulator located on the outlet of the pump head. Turning the adjustment screw clockwise will increase the pressure. Watch the gauge when adjusting the pressure. Once pressure stops increasing, discontinue tightening the adjustment screw. Tightening the screw all the way down can cause the regulator to malfunction and cause damage. The belts should be kept tight enough so that they have half-inch movement to either side of their normal resting position. Adjustment is made with the adjustment screws located on the bottom side of the pump. If the pump begins to have pulsating pressure, it is usually accompanied with increased noise. It typically means a problem with the regulator or something is lodged in one of the valves. To check the regulator, with the pump running, completely decrease the pressure, then increase it to the original setting. This will likely allow it to pass on through the seat if debris is lodged in the valve. If that does not correct the pulsating and the increased noise, check the pump valve for lodged debris. Since the inlet valves are first to see the water, this is the most likely place to look. Details on valve removal are in the Water Wizard manual. Pressure can be adjusted with the bypass regulator as previously mentioned. However, if the pump is operating smoothly and you are not able to get the pressure up to the 1,000 psi, the problem is usually due to a leak in a high-pressure line or worn nozzles and not the high-pressure pump. For more detailed information, locate and review the CAT pump portion of your Water Wizard manual. If the pumping plant is the heart of the Water Wizard, then the electrical control panel is the brain. It houses the system's computer processor and other electrical controls. The control panel is always to be mounted away from the pumping plant to eliminate undue vibration on the electrical components. All power supplied to the Water Wizard by the local utility company is routed through a main disconnect. Follow the instructions in Chapter 13 to check the incoming and outgoing power for proper voltage. Breakers for the 220-volt three-phase going to the wash bay and the 220-volt single-phase used to power the chemical delivery pumps are mounted to the left of the main disconnect. This is an additional safety factor when setting the bay equipment. If there is a loss of 220-volt power at the wash gantry, check for a trip breaker first. The CAT 3535 motor starter is mounted on the right-hand side of the electrical control panel. Motor starters typically offer very little maintenance requirements. There is a safety overload with the starter. The overload should be set at 70 amps when operating with 208 voltage. Should there be excessive amperage, the overload will trip and need to be reset. The starter will not engage and therefore the pump motor will not run if the motor starter overload is tripped. When tripped, a yellow flag appears in the tripped window. To reset the overload, push the gray button on the lower right-hand side of the starter. You should feel slight resistance and then a release when depressing the button. The yellow flag will then disappear. There is more about troubleshooting the motor starter in Chapter 13. The Water Wizard functions are controlled by a programmable controller, more commonly called the processor. In normal operation, the power and run lights will be on and a communications light will be flashing, indicating communication with the operator interface panel. The processor uses the input and output cards to control the electrical signals to and from Water Wizard components. In basic terms, input signals are sent into the processor by other components, and an output signal is the processor telling the components what to do. Anytime an electronic switching device, such as an optic eye or proximity switch, has been activated, the electronic signal created is received by the input card. This signal will be indicated by the LED above the corresponding wire number. The signal is then sent to the processor. When it is time for the gantry to move or a valve to open, the processor directs the output card to send an electronic signal to that function. There are different voltages used in the output cards. The electrical prints located in your manual and on the panel doors clearly define their location. The entrance sign and the in-bay instructional sign are powered by 110 voltage. Located in the bottom left-hand side of the control panel is the ZOC16 relay card that controls these signs. When called for, the processor sends a 110 volt signal to the top side of the corresponding relay, energizing the relay which activates the bay sign. They can also be activated manually through the test screen on the interface panel. Relays are a plug-in component and are easily replaceable. Use the yellow relay removing tool located on the left-hand side of the card to remove a relay from the ROC16 card. The tool is not necessary to insert the new relay in the ROC16 or to change the relays in the 110 volt ZOC16 card. Terminal strips in the control panel are well marked for easy wiring. As with any terminal connection, make sure only the bare wire is under the connection with no stray wires touching other terminals and that all connection screws are tight. The transformer will convert the 110 volt power to 24 volt. Make sure all connections are tight. Test proper operation with a voltmeter using guidelines in Chapter 13. The operator interface panel provides the operator a hands-on method of controlling and monitoring the system's functions. There are several different functions that can be performed with the touch of a button. The information programmed into the interface panel is communicated through a cable. This cable connects to the RS-232C port on the processor. The processor is located in the upper left-hand corner of the control panel cabinet. The Select Recipe button lets you select which of the possible 40 stored recipes you want to offer your customers. Every Water Wizard is shipped with 20 factory set recipes numbered 0 through 19. These cannot be modified and saved as the same number. However, they can be modified and saved as a number between 20 and 39. This is done with the Change Recipe screen. Of those 20 factory set recipes, 4 have been selected as standard. A complete description of all 20 recipes is included in your operator's manual. To select a recipe, push the Select Recipe button, then push the Enter button until the cursor is on the cycle you wish to change. Enter the recipe number for the desired wash cycle and push the Enter button again. A pass begins with the boom in the home position, travels down, then back up to home or the height adjusted position and travels to the opposite end of the vehicle. The next pass begins when the boom begins its downward travel at the opposite end of the vehicle. The only exception to this rule is the rear pre-soak pass available on Pass 1. When selected, It will allow the boom to make an additional pass at the rear of the vehicle before beginning pass 2. This allows for full pre-soak coverage when only one pass of pre-soak has been selected. This is often the case with a 4-pass wash recipe. To change a recipe, you must first know the number of the corresponding wash cycle you wish to change. Determine that from cycles 1, 2, 3, or 4 on the selected recipe screen. Then push the Change Recipe button. The first screen asks for your password. Enter 1, 2, 3, 4 and push Enter. Push the button beneath the Program tab. The next screen asks which recipe you wish to program. Enter the number of the recipe you wish to change and push Enter. The recipe will then come on the screen in detail. It will show the recipe you are working on, which pass you are currently on, which direction the gantry is traveling over the vehicle, and the product it is applying. The Center tab will let you scroll through all the products available during that pass. The tab to the right tells you if that product is on or off. To turn a product on or off, push the toggle button. Once you are finished with that pass, push the next key to go to the next pass and repeat the process. Continue this process until you have designed the wash recipe to your needs. Remember, wash recipes are in even number passes. 4, 6, 8, and 10 pass wash recipes are available. When changing recipes, make sure only one product is selected on each pass. Once the recipe has been modified, push the Exit button. This will bring back the screen that has the Copy tab. Select the Copy tab. It will ask you what number you would like to assign to the modified recipe. Enter that number and press the Enter button. Then press the Save button and enter again. The word saved will appear on the screen. Then hit Exit to return to the main screen. Enter the new recipe into the selected cycle with the Select Recipes button. As you scroll through the options available for each pass, the last option will always be the boom down timer. This is the amount of time the boom travels in its downward motion. Add more time to have the boom travel lower or less time for less travel. The boom down time is adjustable for each pass to fit your personal needs. The Water Wizard will store income reports for the past 3 years. Press the Income Monitoring button to review that information. Enter your password and press Enter. The first screen will show your daily income beginning with today. Push the Raise button to scroll through the remaining days of the week. The lower button will reverse the process. Pushing the Next button will take you to a monthly income report, and pushing the Next again will go to an annual report. As with the daily, pushing the Raise button will take you through the individual months and years. You can print out the report in any of the formats mentioned if the optional printer is used. Return to the Start screen by pressing Exit, then press the Mute button. You will have to enter your password again and press Enter. The screen will ask which reports you would like to print, weekly, monthly, or yearly. To begin printing, press the tab beneath the report you want. If the transfer message appears on the screen, turn power off to the panel and then turn it back on again. Press the Operation button to monitor the operation of the Water Wizard during a wash cycle. The screen will show the current wash cycle, the pass it is in, and what product is being delivered. This option allows the operator to change the price of each cycle. Press the Change Prices button and you will see the 4 wash cycles and their current pricing. For accurate accounting, these prices must match the entrance controller. Changing prices on the interface panel does not change the pricing at the entrance controller. This option assists service personnel in determining what sensors are on or off. It is also the area in which a number of timers are set. Press the Service Screen button to begin the process. The first screen will show blower timer, dwell number 1 and dwell number 2. Push the next key to scroll to another screen which will show the entrance timer and other options. Scroll to the screen displaying the timer you wish to modify. Use the Enter button to move the cursor to that timer. Enter the new value in seconds and tenths of a second and press Enter again. There are several screen options available, as you will see by continuing to press the Next button. This screen is mentioned in several chapters of this manual. Please familiarize yourself with its options. For detailed information about each of these settings, refer to your operator's manual. The test screen will assist service personnel in troubleshooting and proper adjustment of product application. You can select the product you wish to test by pushing the scroll button until the product is listed on the screen. Once there, push the toggle button to turn that product on and off. You can then set the delivery pressure at the Procom pump or adjust the air to product mixture in the low pressure manifold box. When finished, return to the operator interface panel and toggle it off. You can continue this process with each function available to the Water Wizard. This allows the user to change the password, set the clock, and enter a phone number to be used with the Optic staging system. The first screen will ask for your existing password. Enter it and press Enter. This will take you to the owner settings screen. Press the tab beneath the function you wish to change and follow instructions. For more detailed information, see the Water Wizard manual. A prox is an electrical switch that operates when metal is on or near the head of the prox. We refer to this metal as a prox target. Proxes used on the Water Wizard require a 1/8 to 1/4 inch clearance for proper operation. Any closer may damage the face of the prox. Any further away and the prox may not read its target. Adjustments are made using locking nuts on the threaded prox body. Locking nuts must be secure so the prox doesn't self-adjust. The end of track and home positions proxes are to be mounted on a parallel plane with the prox's travel path to ensure a constant signal over the entire target. Signal wires are connected to the prox using an O-ring fitted screw-on connector. Moisture on the terminal pins can cause false signals. Filling the connection with electrical grease before attaching the screw-on connector will protect the connections. Each prox sends a signal to its corresponding input card through this connecting cable. Location of terminal numbers for a given prox is provided on the control panel doors and in the Water Wizard manual. Before we begin with instructions on troubleshooting, let's look at the prox locations. There are 7 proxes on the Water Wizard. 4 are located on the gantry boom. The top prox is the top boom prox. Below it is the air solenoid prox. Below that is the auto height prox. At the bottom is the lower boom prox. The remaining proxes are located at the bottom of the passenger side of the gantry. At the exit end is the home position prox. At the entrance side is the end of tracks prox. The count-up prox is located on the counting wheel. The service screen is a great tool when troubleshooting a prox. All the prox readings are shown there. Begin by verifying power and communication lights are lit on the input card. This will verify power and communications between the gantry and the processor. The first test of a prox is to determine if it is going on and off. Go to the service screen and scroll to the prox you wish to test. A list of their normal at-home status is listed in the operator interface panel section of the manual. If the prox has power and is working, an LED light on the prox will light when metal is near. When the metal is removed, the light should go out. The next step is to view the on-off status of the same prox on the service screen. The on-off status should change when metal is present and removed. If the light on the prox is on and the on-off status does not change, examine the cable and connections at both ends. The signal is also indicated on the input card in the gantry control panel. The corresponding light should go on and off as the signal changes. If the light on the prox will not light when metal is near, look for loose connections at both ends of the cable and check the cable for breaks. If power and communications are present and cable is okay, replace the prox and retest. This prox is mounted in a position to read target flags as they pass by. The flags are mounted on a wheel that rolls along the track as the gantry moves. The wheel is held tight against the track by a spring. Inspection of this spring and the wheel should be part of your weekly maintenance. This prox's signals are counted by the processor. These counts are used in conjunction with the gantry eyes to locate the vehicle in the wash bay. This prox is factory set for distance but should be checked routinely. Optic sensors, or eyes as they are commonly called, are in sets, a transmitter and a receiver. They must be perfectly aligned. When the transmitter sends a signal to the receiver, it completes a circuit. That circuit is broken when blocked by an object. The Water Wizard uses the signals created when that circuit is broken and reconnected to locate objects in the wash bay. On the bay floor are eyes at the entrance and at the treadle plate. The entrance eyes signal the start of the wash as the vehicle enters the wash bay. Treadle plate eyes are to detect the vehicle in position to receive its wash. On the gantry, one set of eyes detect the height of the vehicle in the bay. These three sets of eyes are banner eyes. They have built-in amplifiers and are self-contained. In the center of the gantry are the gantry eyes that mark the front and rear of the vehicle. The boom eyes are on the exit end and outside the gantry. These are safety eyes, ensuring clearance for the boom to lower at the rear of the vehicle. These eyes are telco eyes and have amplifiers located in the gantry control panel. Refer to the manual for proper amplifier settings. Using the service screen, determine the normal at-home and no vehicle in the bay status before checking operation of the banner eyes. You'll find them listed in the manual under the Operator Interface Panel tab. To change the status, block the eye and check the service screen. If it does not change, check for a red light on the transmitter eye. The transmitter's model number is labeled with EQ and is located on the passenger side of the wash bay and the gantry. The red light indicates that there is power on the transmitter. If there is power on the transmitter, check for a red light on the receiver. Check the connections and for proper alignment. Screw-on connectors should be filled with electrical grease to keep out moisture. If connections are okay, replace receiver eye and recheck operation using service screen. You can check the operation of the telco gantry eyes in the same manner. Look for a change in the on-off status on the service screen. If status does not change, check the lights on the Optic amplifier in the gantry control panel. A yellow, green, and power light should be on. A red light on LT indicates a bad transmitter. A red light on LRT indicates a problem with the receiver. If both lights are on at the same time, swap amplifiers and see if the problem moves. If so, replace the amplifier. If the amplifier lights are okay and on-off status does not change when the gantry eyes are blocked, check for eye alignment using the Optic tester tool. Replace one of the amplifiers with the Optic tester. Indicator light should be between A14 and B1. A14 is the best possible signal. B1 is the lowest acceptable signal strength. If the eyes will not read, replace receiver eye. On the telco eyes, the letters LT are on the transmitter and LR is on the receiver. The undercarriage solenoid is located in the front center portion of the pumping plant. This valve opens during the undercarriage portion of the wash cycle. The high-pressure solenoid on the gantry remains closed and the medium-pressure solenoid opens. The valve has two different areas to check if problems arise. First, remove the coil. Do not remove the coil with power on it. Doing so will cause it to fail. After removing the coil, remove the stem and check for free movement of the spring and valve needle. Check for debris in the needle seat. If clear, replace the stem and then the coil. If the problem still persists, remove the 4 screws from the plunger housing. Once the cap is removed, you will find a spring and a valve plunger. Remove the spring and then the plunger. You will note the plunger has a plastic gasket on the bottom side. Gasket should be free of debris and the seat clean and smooth. The plunger also has a spring-loaded ring gasket. It also must be clean and should move freely. These solenoids are located in the high-pressure manifold box on the gantry. They control the flow of high-pressure water. One valve controls the top boom and the other the side nozzles. These valves close when rocker panel sprayers and undercarriage are called for. The high-pressure solenoids are serviced in the same manner as the undercarriage solenoid. See that section for instructions. This solenoid is also located in the front center portion of the pumping plant. When selected, it opens and allows a portion of the high-pressure water to return to the water holding tank. Maintenance and repairs the same as the undercarriage solenoid. Please see that section for instructions. There are several low-pressure solenoids that control the flow of products such as triple shine, pre-soak, tire cleaner, and air. They are located on the gantry in the low-pressure manifold box. For detailed information, see the low-pressure manifold drawing in your manual. The clear coat protectant and soap solenoids are located on the pump unit. Valves open when called for to allow product flow into the cat pump. The low-pressure solenoids are simple to maintain. Begin by removing the coil from the stem. Never remove the coil when there is power on it. Doing so will cause the coil to fail immediately. Once the coil is removed, remove the stem by turning it counterclockwise. The removal tool shown is available through our parts department. The stem contains loose components. Be careful when removing. Verify the plunger and spring move easily and there is no damage to the seat. Check for any blockage in the valve body. If none, reassemble the valve. Air and water flow from the pumping plant to the gantry must be regulated. These regulators are a standard part of every Water Wizard pumping plant. Any adjustment made to a regulator should be done when product is flowing. This air regulator is located on the pumping plant framework. 100 psi is the proper setting. The low-pressure regulators are located in the low-pressure manifold box on the driver's side of the gantry. These regulate the air pressure to product ratio. Adjusting the air pressure will produce a more or less foamy consistency in product application. To adjust pressure, lift the adjustment knob and turn it to the right for increased pressure and to the left to decrease it. Remember, the air pressure should always be less than the product flow pressure. Usually there is a 10 to 15 pound difference. This regulator is located on the outlet side of the CAT 3535 pump. It is a simple piece of equipment. It operates by spring, a stainless steel plunger, and a seat for the plunger. Tightening the adjustment screw will apply pressure on the spring and increase the outlet pressure. Pressure should be set at 1000 to 1100 psi. In a variety of fault conditions, the Water Wizard will issue an error code indicating the type of fault, the time and date, and the location. They will automatically appear on the operator interface panel and will print out if a printer is available. The system will store the last 10 faults for review at any time. Push the alarm button on the interface panel for a list. Push the next button to scroll through them. During the explanation process to follow, we talk about the proximity switches and optic eyes. Refer to the Water Wizard manual for a detailed list of these switches and their normal on or off position. After noting the fault condition, you will need to clear the PLC computer by pressing the reset button before correcting the fault. First, look at pre-soak level in the Hydraminder tank. If the tank is full of liquid, turn off the tank heater and allow liquid to cool before going any further. Then make sure low-level float switch is in the horizontal position and not being held down by a hose or some other object. Review the pre-soaked tank status on the service screen. If the tank is empty, check for liquid in other tanks and that city water is available. If water is present in other chemical tanks, check for a stuck float and that the quarter-turn valve is open. If all is okay, turn off the water and check the screen filter on the Hydraminder inlet. If the screen is clean, follow the service steps under the Hydraminder chapter for valve repair. For these fault conditions, follow the same procedure as the pre-soaked tank empty fault. Note that the float switches for the clear coat tank and the triple shine tanks are wired in series. Any of the 4 tanks will send this fault signal. When pressed, the button will have to be manually reset. Check printer tape for history of faults. If there is not a printer, push the alarm button and scroll through the fault history. Follow the necessary steps for the corresponding faults. This is an informational fault. The Water Wizard will reset automatically. If this happens repeatedly, the treadle plate optic may be faulty. Reset the operator interface by pushing the exit button. The Water Wizard recipe probably includes too many slow passes. Reprogram wash recipes to include more regular speed passes. This fault can also appear if the gantry is hanging up on the track. Refer to the Danfoss Variable Speed Drive section of the Water Wizard Manual for operating instructions. Check P73, 74, and 75. These are the last 3 fault codes recorded. Note these, then refer to the Danfoss Manual for a list of fault code descriptions. Then follow the recommended steps for troubleshooting. This fault will also shut down the entrance controller. For these fault conditions, follow the same instructions as the drive motor section. The Water Wizard will record a fault condition generated by the entrance controller. Refer to the entrance controller's instruction manual for service. If the drive motor runs more than 2 minutes, this fault will display and the processor will disable the entrance controller. When troubleshooting, first determine the location of the wash gantry. If the gantry is in the middle of the track, check for a physical blockage and that the track is straight. Then check for a loss of power supply to the gantry. Check for power lights on the input-output cards and the Danfoss motor drives. If the Danfoss motor drives have lost power, begin by checking the breaker in the control panel. If the breaker is not tripped, use a voltmeter to check for voltage at the gantry control panel disconnect. Checking voltage instructions are in Chapter 13. Then check wiring from terminal strip to drives. If the power light is off, check for 24-volt DC power on the terminal strip and connections to the output cards. If power is not present at the terminal strip, check for 24-volt DC power at the power supply located in the control panel. If power is present at the supply and not at the gantry, check the 4-conductor gray cable and replace if necessary. If the communication lights are not lit, check the connections at the gantry terminal strip and the 4-conductor gray cable. If the gantry is stuck at the entrance or exit end of the tracks, check the corresponding proximity switch. Refer to the prox section for proper operation and troubleshooting. If a fault is present and the unit is still operating, check both end of track and home position proximity switch adjustment. Also check for loose connections or worn cables. If the top boom motor runs for more than 20 seconds, this fault will display and the processor will disable the entrance controller. To troubleshoot the fault, note the boom's current position. The boom has 4 different proximity switches that send a signal to the processor indicating the boom's current location. If the boom is in the home position, check the input cards for a communication light. If the communication light is on, check the top proximity switch for proper operation as described in the prox chapter. Replace the prox if necessary. If the boom is not completely at home, check the Danfoss drive for proper operation and physical obstructions by putting the system in manual mode and raising and lowering boom. This feature looks at the top boom prox to see if it goes off after the top boom motor has run for 2.2 seconds. This fault condition does not disable the entrance controller. Use the manual mode to raise and lower the boom to help locate a possible obstruction. The Water Wizard performs a diagnostic check on all proximity switches at the beginning of each wash cycle. If any of these proxes do not report the proper on or off signal for startup, the processor will report a fault. Check the top prox for proper operation. It is possible to get this fault in the top prox not to be the source of the problem. If the top prox is on and the auto height prox is on at the same time, this fault will be displayed. The auto height prox then needs to be investigated. This program looks at the height adjustment prox during the first 1 second of the wash cycle to see if the prox is off in its at home position. If the prox is on, we display this fault condition, disable the auto height adjustment feature, and continue to wash vehicles. Verify the prox fault by raising and lowering boom and checking its operation on the service screen. The program looks at this prox during the first 1 second of the wash cycle to see if the lower prox is off in its at-home position. If the lower prox is on, this fault message is displayed and the entrance controller is disabled. This program tests the operation of the home prox during the first 1 second of the wash cycle. The proximity switch should be on at this time. This prox is tested during the first 1 second of the wash, and the program looks to see if it is off. If the prox is on with the gantry in the home position, then we display this message and disable the entrance controller. See Chapter 8 for troubleshooting the prox switch. This program tests the eyes to see if they are on during the first second of the wash cycle. The height adjustment eyes are also checked for proper operation when the boom is lowering at the rear of the vehicle during a high-pressure pass. The boom, when tilted toward the rear of the vehicle, will block the eye when it lowers. The program checks to see if the signal goes off when blocked by the boom. If the eyes do not pass both of these tests, this fault condition is displayed. The water wizard will continue to wash vehicles but will not adjust to the vehicle height until these conditions are met. The program tests the air solenoid procs at the beginning of the wash cycle to make sure that it is on during the first 1 second of the wash cycle. If it is off, this message will be displayed, but the entrance controller will continue to operate. This program checks to see if the top procs becomes uncovered for more than a half of a second when the gantry is moving down the track. If this occurs, the fault condition is displayed and the entrance controller is disabled. Check the condition of the brake motor. This chapter will demonstrate how and where to test for proper voltage. These tests should only be performed by qualified electrical technicians. You will be dealing with live 220 and 110 volt circuits, so there is a chance of electrical shock if not handled correctly. The high pressure pump will not run and the gantry will not move. These are symptoms of problems with the 208-230 three-phase voltage. Begin the check for 208-230 volts at the sources first. Make sure incoming power is on and the designated breaker is not tripped. Check that the 220 breaker in the control panel is not tripped. Next, check for proper voltage at the top side of the main disconnect on the control panel. Test voltage between terminals L1 and L2, then L2 and L3, and last L1 and L3. Voltage should be between 205 and 240. Then go from each leg to ground. Voltage there should be 110 to 120 volts. In some cases, due to the type of three-phase power available in your area, one of these legs may read higher than 110 volts. Different symptoms indicate different problems. If the pump motor will run but the motors on the gantry will not move, first check the 220 breaker in the control panel and that the gantry disconnect is in the on position. Then check for voltage on the top side of the breaker and then the bottom side. If power is present on both sides, we now need to check power at the gantry. In the gantry control panel, check for 220 power at the top side of the gantry disconnect switch and then repeat the process on the bottom side. If there is still no power, the problem is likely in the 12.5 SO cord. The gantry motors operate, but the cat pump motor will not run. Verify the service screen reads water tank OK. If so, the problem is likely in the motor starter overload or less likely the starter itself. First, see if the overload is tripped. If so, press the reset button. Notice when the overload is tripped, a yellow flag is present in the tripped window. When it is reset, the flag is removed. The motor should run after the overload is reset. If the overload is not tripped, check for voltage at the top of the starter following previous instructions on checking for 220 volt power. Power must be present on all legs or system will single phase and not run properly if at all. If the overload is not tripped and the starter is pulling in but the motor is still not running, the contacts within the starter are faulty and the starter needs to be replaced. If the overload is not tripped and the starter does not pull in and you have a signal light on the starter relay, check for 110 power between the A1 terminal on the top of the starter and ground. If there is no 110 volt power, check the fuse on the ZOC16 relay card and verify 110 power on the top and bottom side of the fuse housing. If 110 power is present, check for a loose neutral wire at the starter. Make sure incoming power to the building is on and the designated breaker is not tripped. Symptoms indicating problems with the 110 voltage would be no display on the interface panel and no power lights on processor or input-output cards. Check the incoming power from terminal 37 on the auxiliary switch in the control panel to ground. Then check from terminal 38 and ground. There should be 110 volts present on both locations. Then check for power between terminals L and N on the 24 volt power supply and on terminal strip number 1 between the 110 hot and 110 neutral. Be sure to replace the protective cover. Your final check is at the transformer between H1 and H2. 110 volt power should be present at all locations. Check the 110 fuse on the ZOC16 relay card. Symptoms would be that the chemical motors will not run and the solenoids will not open. Begin by checking the 24 volt fuse to the left of the spot-free rinse relay. If the fuse is okay, check for 24 volt power between terminals 1 and 3 on terminal strip number 1. If no voltage is present, check for power on terminals X1 and X2 on the transformer. Verify that the transformer has 110 volt power to it. If the chemical motors will run but the solenoids on the gantry will not open, check for power at terminals 1 and 3 in the gantry control panel. If power is not present, the problem is likely a damaged SO cord between the equipment room and gantry. Symptoms would be no power on the interface panel and no lights on the input-output cards. Begin by checking for a green light on the DC power supply located in the upper left-hand corner of the control panel. If the light is not on, verify 110 incoming power between terminals L and N. If 110 is present, remove the blue wires on the top left-hand side of the power supply. Once the blue wires are removed, verify the DC power supply is operating correctly. Check for 24 volt DC power between terminals V negative and V positive. If 24 volt power is present, the problem is likely a short in a component associated with one of the wires or the wire itself. Reconnect the blue wires one at a time until power is lost again to determine which circuit is causing the problem. If you have lights on the input-output cards on the control panel, but none at the gantry control panel, then check for 24 volt DC power between terminals 5 and 7 on the gantry terminal strip. If no power is present, make sure all cable connections in the gantry control panel are secure. If connections are secure, the problem is likely in the 4-conductor gray cable between the equipment room and the gantry. All information contained in this video is current as of January 2002. In working toward that 100% uptime goal, Jim Coleman Company does reserve the right to make changes in equipment specifications. Jim Coleman Company is very interested in your success. Thank you for taking time to view this video. For additional information and support, contact Jim Coleman Company's service department or your local distributor.